All right, 5.1 proportionality. This is our first problem. Let's go to the notes. And of course, it's not showing. All right, so yeah, I'm in the right. Yeah, I'm in the right section. 154. All right, so the distance you drive is proportional to the amount of gas used. Driving 100 miles, it uses 5 gallons of gas. And fill in the table. This is gas distance. All right, so you got gas. It says driving 100 miles uses 5 gallons of gas. So miles per gas. So it's 100 miles per 5 gallons of gas. So that's 20 miles per gallon. So what I would do is take that gallon of gas and multiply it times that 20 to figure out the distance. So in other words, that'll be, and if you look at your conversions, remember we talked about conversion factors before. If I have 0 gallons over 1, I want to convert it to miles, then I'm multiplying it by that 20 miles per 1 gallon so that my gallons can cancel. And that leaves me in the conversion of miles, or the measurement of miles. So that's essentially what we're doing. So of course 20 times 0 is just 0. But then 20 times 5 is 100. 20 times 10 is 200. And then 20 times 15, 300. All right, questions on that? And like I said, it's very similar to what we've done before.
Wait, my 20, where does my 20 miles at?
What do you mean, where is that? Where did it come from?
Yeah, real quick, just so I can write it down.
Right here. It was 100 miles per 5 gallons of gas. So I did 100 divided by 5.
You got 20, and then you took 20 and you just divided it or you just multiplied it every single time.
Uh-huh.
Okay.
Yep. All right, B, represent the relationship between distance driven D and gas used G with an equation. So if you look at what we did,
Right.
distance is equal to 20 times the gas. All right, that's what we did here. We took the 5 multiplied times 20, took the 10 multiplied times 20, took the 15 and multiplied it times 20. And that's what we did.
Okay, that was easy. That's good. Are all of them similar to somewhat this?
Using the same relationship. What's the
Right.
equation that represents the best graph? 5 gallons at this point at the origin. Have we talked about plotting points in this class?
Like
I
in
don't
the
remember. Like
beginning
on a.
graphing, in the very beginning, but it was
I think it was only for like one problem though.
yeah.
So, okay. All right, so let's go here. They do ask us to plot the points because really all we would do is plot. Take one of these points. We could take 0, 0, and then 5 and 100. But I just want to make sure we're clear on plotting points first. Because they asked us to do that with C, just plot the line. Yeah, that's right. Because this type of class, you guys supposed to be pros at plotting points anyway. It's a quick recap. All right, so your Cartesian coordinate plane, we talk about plotting points. Your origin is 0, 0. That's where your x-axis and y-axis intersect. X-axis is your horizontal axis. Y-axis is your vertical axis. They split up into 4 quadrants going counterclockwise, quadrant 1, 2, 3, and 4. To get into quadrant 1, you have to make 2 positive moves. Quadrant 2, negative, then positive. Quadrant 3, 2 negative moves. And quadrant 4, you make a positive move and negative move. What I meant to put is the fact that everything to the right of your origin is positive, everything to the left of your origin is negative, everything above your origin is positive, everything below your origin is negative. So that's what I meant by your positive moves and negative moves. Also, you will be graphing by what we call ordered pairs. Called ordered because your order matters. X comes before Y. Horizontal move first, then your vertical move. They actually touch on this more in the next homework assignment in 5.2. They actually ask you to plot specific points. All right. So just to make sure we're clear. So if I wanted to plot 1, 2, I would go to the right one and up 2. Always start at your origin, go to the right one, up 2. If I wanted to plot negative 4, 5. I would go to the left 4, down 5. So negative 4, negative 5. Left 4, down 5. Negative 3, 2. I would go to the left 3, up 2. And 1, negative 4, I go to the right 1, down 4. Just a quick, like I said, quick run through on graphing. Questions on that before we actually
No.
anywhere else? If I had a point that was on the x-axis, it would be my y would be 0. Any point that's on the x-axis, your y is 0. So if I look at here, this point right here would be 3, 0. I went to the right 3, but then nowhere for y. Same thing if I had a point on the y-axis, then x would be 0. So let's say if I had 0, this point right here, that would have had to be 0, 3, because I didn't move to the left or right. So that's why x is 0, and then I went up 3. All right. Questions. So going back to the last problem. One of the points, the first point was 0, 0. So what I can do is, if I look at my increments, I can let my distance, let me see what they did in the book, because I believe distance can be your y. Yep. So down bottom, I would call this my gas, call my y-axis my distance. I would do those in my gas in increments of 5, do my distance in increments of 100. So in other words, let's go purple. It'll be 5, 10, 15, 20, so on.
We can have different types of increments on the x and y axis.
Yep, as long as you're consistent in what you're doing.
Okay.
Yes, sir. So, and then on the y-axis, I would go up by 100s. So what you couldn't do is do 100, 105, then jump to 200, and you know what I mean? Like you couldn't do anything funky. Whatever you do on the x-axis need to stay that way, and then whatever you do on the y-axis need to stay that way, and you'll be all right. All right, so the first point was 0, 0, and then I can go 5, 100, and that's all I need is 2 points to create a line. All right, questions on that? Next one is now they have a few, like 2 or 3 more that's just like that one, but the next one is a little different. To add one other element to it, to the details. Could have just wrote KWH. All right, so your monthly electric bill is proportional to the number of kilowatt hours, kWh, of energy used at a rate of 7.2 cents per kilowatt hour. There's a monthly base charge of $32.50. All right. So they give us a chart like they did before. We got 0, 200. I skipped the line. 200, 400, and 600. All right. So what we have here is we can let let's let X be energy, or in other words, kilowatt hour. And so the way we can write this, and Y would be our cost. And if we notice what the problem set us up for, our monthly electric bill is proportional to the number of kilowatt hours of energy used at a rate. Our rate is 7.2 cents per kilowatt hour. And there's a base charge of $32.50. So when I go to set up this equation using Y and X, I can do 7.2x, that's the rate. So every time you have something to plug in for energy, every time you have an energy increase, it's going to increase by a rate of 7.2. But then also there's a base of 32.50. So the one we had initially, when we were looking at that rate, it increased what was 100 gallons, 100 miles per gallon. So it was 20. But there was no base that you had to add to it or subtract from it. So here they give us a monthly base. So in other words, even if I don't use up any energy, I'm still going to have to pay $32.50 because that's the monthly base charge. So in other words, if X is 0, and all we would do is plug in each one of these individual values, 0, 200, 400, 600 in for X, and then get the value that comes out after we finish our calculation. So if X is 0, that means the cost would be $32.50 because 7.2 times 0 is 0, but we still have a charge of $32.50. All right, do the same thing for the other 3, plug in 200. Let me see, 7.2. Yeah, you didn't do my decimal. Hold on. Is it 200? Oh, I left off the cents part. I'm about to say my number's not coming out right. So that's supposed to be 7.2 cents per kilowatt. So I need to take it over 2 decimal places. 7.2 cents. Why would they give it to you like that? That's weird. Okay. Anyway, it's not just 7.2. Let's go back here because it says 7.2. So make sure you're careful with that. 7.2 cents. That's actually going to be 0.072. All right. So let's take our should be 0.072. I think that'll give me the number that I want. So be careful with those measurements and wording. 200 plus 32.50. Yep, that's the number I need. So that'll be 46.90. So the actual, let me write it like this. So the actual function is y equal to 0.072x plus 3250. And if I were to do this math, 0.072 times 200 is 14.4. And that's 46.90. And so you would do that same thing for the 400 and the 600. All right. Questions on that before we go any further? Then in B, they ask you the same thing that we did back in B of the last problem. We're going to give you, where you go? They give you the variables, D and G. In this case, they give you C for cost. Represent dollars, yep, C for cost. And then E for energy. And just ask how would you write that, and they give you the blanks and you just fill them in. So that would be C is equal to 0.072 E plus that 32.5. So it's the exact same thing. It's just that they changed the variables. If we wanted, we could start off with those variables. Then they ask you to graph it, like we did before. So you would plug in. Did they ask you to graph?
Yeah, they asked you to graph it.
Yeah. So you plug in values. Well, really, you already have your values right here. So you would graph those. And they give you they give you the increments and stuff. So you would graph those. And that'd be good to go. Or graph either one of these points. You only need 2. You only can graph 2 as far as my math lab is concerned, even though you'll have 4 points. So you just pick 2 out of those 4 and it should give you a graph. If you have any trouble graphing or with the lines and all the stuff, just make sure you get with me. All right. Another type of problem. I think this is more so, yep, this is number 12. There's only 13 problems in there. So this didn't have that much of a variation of problems in this section. So it says determine which ordered pairs satisfy the given equation. And it gives us a few ordered pairs to try. So the first one we're looking at, 2, 3. And what do you mean by satisfy the given equation? I mean, is it a solution? The way you would know that is by plugging it in and see if you get a true statement. Don't forget, the order is that the first value is x, second value is y. And you plug that in accordingly. So we have x plus 4y equal to 14. So it's going to be 2 plus 4 times 3 equal to 14. 2 plus 12 equal to 14. 14 equal to 14, which is true. So that will work.
So you're just checking to see if the work's correct, pretty much.
Say again now?
You're just checking to see if the work is correct while plugging it in, seeing if it adds up.
Yep. See if that order pair, when you plug in that order pair, will it work? Will it give you a true statement? Yep. Let's do another one. Let's go 0, -3. All right, so do the same thing. X is 0 this time. -3 is y. So that'll be 0 plus -12. -12 equal to 14. So no. That's all there is to that one. So before we look at 5-2, questions on what we did there? Let me see. Let me write this. All right, so we're looking at slope and y-intercept in this 5.2 section. So your slope is going to be the rate of change. We have already alluded to that to some degree in that first section. But your slope is going to be the rate of change for a particular value or a particular situation. It's also going to be the steepness or the incline of your line, like the slope of a mountain, slope of a ramp, slope of your roof. It's actually putting a numerical value to that incline or that steepness. So the way we will calculate it, M is the letter we will use for your slope. Can't use S. Physics has already taken S for other things. So we're using M for your slope, where we do y2 minus y1 over x2 minus x1, or we can do y1 minus y2 over x1 minus x2. And I'll show you in a second why it doesn't matter as long as you stay consistent. Notice if you use y2 first on top, make sure you use x2 first on the bottom. Or if you use y1 first on top, make sure you use x1 first on bottom. Also represents rise over run. Your top number will be your rise. Your bottom number will be your run. In other words, your top number is your y, which is up or down. Your bottom number is your x, which is right or left. And x1, y1, x2, y2, hold up. Yeah, x1, y1, and x2, y2. Yeah, that's right. Will represent 0.1 and 0.2, and they are any 2 points on your line. any 2 points on a line or any 2 points that your graph or your function creates will help you to find your slope. Also, we have your slope-intercept form of your equation. That's y equal to mx plus b. So if you have your equation solved for y, your linear equation solved for y, which are the only equations that we're dealing with. So if you have your linear equation solved for y, the value that is in front of your x or attached to your x is your slope, and b is your y-intercept. Characteristic of all y-intercepts is that x is 0. So that means the ordered pair for your y-intercept would be 0, b. So they don't spend so much time on this because they expect you to be pros at this, you know.
Right. Dang.
So this part, yeah. So just telling you the mindset of the book. But I'm pretty sure they mention it, but they just don't sit on it. You know what I mean? Like it's not a separate section and stuff. All right. So, and I'll just put 0 right there. X is always 0. And then for your y-intercept, just for a side note, not y-intercept, for a side note for your x-intercept, so side note for your x-intercept, y is always 0. So for your y-intercept, x is always 0. For your x-intercept, y is always 0. And we talked about that a little bit last section when I said that you have points that intercepts or that will be on your x-axis or be on your y-axis. So that's what we're talking about there. So if I have an equation that's in the form of y equal to 4x minus 5, my slope is 4, my y-intercept is negative 5. So that's all that we're saying, that if your equation is in that form, and also that means that if my y-intercept was negative 5, x is equal to 0. Notice for my slope, a lot of people make the mistake. You say, what's the slope? They'll write 4x. Your slope is not 4x. Your slope is just 4. Do not include that variable as a part of your slope. Questions. So let me go back to your where's 5.2? Here it goes. All right, here. So yep, you guys should be able to see it. So notice it has a line of y equal to, I don't think I can write on this now. You see it right there, y equal to negative 0.13x plus 281.75. All right, so what is the slope of a linear trend line? That's just going to be negative 0.13. All right, then it says in real world terms, fill in the blank. So the should be per capita beer consumption. That's the top. If you look at the top of your graph, that's the title. You're talking about per capita beer consumption is changing by negative 0.13. Years per gallon. So your years is down bottom. That's your X. That's what's being affected by the negative 13. And it's per gallon, which is your Y. Let me see. Oh, wait, hold up. I meant the other way around. Because Y is on top. It's per, yep, hold on. It's the other way. It's gallons per years. Let me check. Maybe my green. Yep, I'm good. Yep, so it's gallons per year. Sorry. Remember when you do your slope, Y is on top, X is on bottom. So it's Y per X. So your Y is gallons, and your X are the years down bottom.
Okay.
All right, so. Questions on that before I leave it? All right. Okay, that's the same thing. Same thing, they give you the slope and stuff and all that. Okay, so here it's a little different. In words describe the function. Okay, let me see if I got one without giving you this, because this one gave me, okay, yeah, that's fine. All right, so what we can do, if you want to know what the rate, remember your rate is your slope, we can get points here. Notice we have 0, 0, we can use that as a point. And the other solid point that we have is 1, 4, right up here. You know, it's right there in that corner. So that's our solid point. So let's go to our notes and I'll show you what I mean. So we went on the graph and we saw that we had 0, 0, and we can call that x1, y1. And we had 1, 4, x2, y2. All right. So if I want to find the slope, remember what he said we can do is y2 minus y1 over x2 minus x1. As a matter of fact, I'm going to do both of them just to show you that either way you'll get the same answer. But remember, you only have to do one way. But either way, you'll get the same answer. Just have to be consistent. If you use y2 first on top, use x2 first down bottom. If you use y1 first on top, use x1 first down bottom. So y2 is 4 minus y1, which is 0. And then, hold on. Let me go back. Was that 1, 4 or 4, 1? Just use to the right one up 4. Yep. Okay. Right one up 4. Yep. So, and then here, 1 minus 4. So that's 4 over 1, which is just 4. There's no guarantee you'll always have a solid number. You may have, you know, it could have been 1/4, you know. So you don't have to convert to a decimal or anything, but you do write it as simple as possible. And then here, y1 is 0. Y2 is 4. Then x1 is 0. X2 is 4. X2 is 1, excuse me. So that's -4 over -1, which still give you +4. So questions on that calculation before we go any further?
No, you're just gonna have to play. I'm just gonna have to play with it. You know what I mean?
Yep. Mm-hmm. All right. So let's go to, why it's not coming up? Let's go back. Let's put it up. All right. So according to the function, the rain depth decreases by 4 inches every 1 hour, decreases 1 inch every 4 hours, increases 4 inches every 1 hour, and then increases 1 inch every 4 hours. So first thing we got to do is go back. I know I keep jumping screens, but you know, that's how it is. Let's go here. Positive slope means increase. Negative slope, decrease. So we have a positive slope, so that means we'll be increasing. So that eliminates the first two options. Then also make sure we're okay with what y represents and what x represents. When you go to your chart, let me go here, right, purple. Y is, let me just y equals inches. And then x equals, I think it was hours. I'll go back and check. Yep, hours. So what we have is our slope is 4/1. So that's, remember, y is on top. So that's 4 inches for every 1 hour. It's going to increase 4 inches for every 1 hour. All right. All right. Excuse me. And they also have one other question. Calculate the slope, represent the change. If it was a fraction, you would type it in as a fraction. And then we just said it was inches per hour. And that should be that. Yep. Oh, this one. It is a good model if the rate of rainfall increases over time, if the rate remains consistent. So if your rate is going to stay at 4 inches per hour, then it's a good model. But if it doesn't, if that rate is going to increase, then of course this wouldn't be a good model, because that means that 4 would be different. So that's what we're talking about there. All right. Questions? Almost finished, I think. Yeah, I got a few more. So the next one asks us to find the slope. And they give us -2, -10. And 2, -8. Decide which one you calling x1, y1, and which one you calling x2, y2. And then plug them in. Remember I said y2 minus y1 over x2 minus x1. So y2 is -8. Make sure you don't lose a negative. So there's a minus sign in your formula, plugging in -10. And that'll be x2, which is 2, minus -2, which is x1. So negative to negative turns positive in both cases. -8 plus 10, 2 plus 2. So that'll be 2/4, which is 1/2. All right, questions. So the next one, a person's annual salary increases by 10,000 over a 10-year period. Find the average rate of change of the salary per year. All you would do is take, because this is over, it's 10,000 over 10 years. So you would just take 10,000 divided by 10 if you want to know per year, how much it increased per year on average. It would just be 1,000. Problems with that? Problems?
Just been a minute since I've done like slope or YX, so that might take me a second just to, you know what I mean, get in there.
Yeah, not a problem. Let's go. I don't need to do that. I need more room. All right, so your basic behavior of your slopes. If you follow your line and it goes up, if you're going from left to right, it goes up. That means your line is increasing. That means your slope is positive. It's going down. Your line is decreasing. Means your slope is negative. If you have a horizontal line, your slope is 0. If you have a vertical line, your slope is undefined. All right, 1, 2, okay. So if I have y equal to 5, your equation normally fits the form of, let's see, y equal to 2x plus 1. In other words, a y and an x is involved in your equation. But if you only see y, that means when you go to create an xy chart, it doesn't matter what x is. This means that y is always 5. So x can be anything, but y is going to be 5. So no calculation, just observation. And so if you plot those 3 points, go to the left, start at your origin, go to the left one, up 5. 0 for x, so you don't move right or left and just go up 5. Then go to the right one, up 5, you'll get a horizontal line at 5. So when you have y equal to a number, it will always produce a horizontal line. All right. So instead of y, if I had x, it's the same effect. It's just that it will be for your x instead of your y. X is always, in this case, always -2. You don't see any y variable. All you see is x. So that means x is the number that they give. So it doesn't matter what y is, x is going to be -2. So if you graph those 3 points, go to the left 2, up 1, left 2, up 2, left 2, up 3, and you get a vertical line. I'm going to try to stay consistent, so I'm going to pull purple back out. So, and so here you get a vertical line. So whenever you just have x involved, that will give you a vertical line. So we got one more to make sure we're good with, and we'll close out. So let's say they tell us to graph 4x, y equal to 4x minus 5. So they didn't give any instructions on what method to use to graph. So it's up to you. I'm assuming that since we're in the slope section, your y-intercepts, that they probably want you to use your slopes to graph. So we'll look at that method. That's not the only way that there is, though. But we know that since it's in slope-intercept form, y is solved, and everything's simplified on the right. I know my slope is 4, and I know my y-intercept is -5. Now, I didn't talk about the instructions that your slope gives. So your slope, we mentioned, is rise over run, which means up top, you're either going to go up or down because of that number. And then that bottom, that run, means you're going to go right or left. So what that means is that you're going to have positive moves, which is up and right. And you'll also have negative moves, which are down and left. So according to what you have, that will dictate how you move. Your slope is actually a set of instructions on how to graph. So if my slope is 2/3, that's a +2 over a +3. So that means I'll go up 2, right 3. if my slope is -5/11, I always tell people to just give the negative to the top number, but it has to go to either or. You can't assign that negative to the top and bottom. It is not -5/11 because, negative over negative would be positive. And you don't have two negatives, you just have one negative. So I would just give the negative to the top number. So that'll be down 2. Oh, not 2. Down 5. Right 11. All right. So you have a -5, right, over a +11. So before we go back to the problem we were looking at, questions on the instructions that your slope gives. All right. So we were at, our slope is 4. Y-intercept is -5. We said for our y-intercept, the coordinate of our y-intercept is going to be 0, -5. X is always 0. Here I have a +4 or a +1 as a fraction. Don't forget your number standing alone means that you have 1 in the denominator. So that's going to be up 4, right 1. So to use this information to graph, you will graph the y-intercept first. Make sure you do that first. A lot of people make that mistake. And then you will generate another point. Let's say from the y-intercept. So you generate another point from the y-intercept using your slope. You do not go back to your origin. Remember, your y-intercept is not a point. It's going to help you generate a point from the y-intercept. That's why you have to graph the y-intercept first. So a lot of people make that mistake as well. So make sure you're careful. We've got enough tick marks. So graph the y-intercept first. So that's 0, -5. It's right here. Now from the y-intercept, I'm going to go up 4, right 5. So 1, 2, 3, 4. Hold up, up 4, right 1. I said up 4, right 5, but I'll go right 1, right here. So I was at my y-intercept. I went 1, 2, 3, 4, up, and then to the right 1. And that would be my line. And you can continually generate points on that line. And that's what that line represents. It represents all the points that that equation would create or generate. If I continue to go up 4, right 1, up 4, right 1, up 4, right 1, it'll continue to make points on that line. Questions.
Just got to get used to it and all that stuff. Yeah.
You are absolutely right. I know some of y'all haven't seen it in a while. One other quick way of doing it, you could use or create an XY chart where you would choose the values. Remember I told you my math lab only need 2 points. You choose the X values and plug them in, find the corresponding Y value. So I chose 0 and 1, plugged in 1 for X. 4 times 1 is 4. 4 minus 5 is -1. So when x is 1, y is -1. Plug in 0. 4 times 0 is 0. 0 minus 5 is -5. So when x is 0, y is -5. And we already saw that from this right here. You're going to get the same points anyway. And then you graph them. So there's 0, -5 down here. And then right 1, down 1. And there you go. Missed my line, missed my point though. So it just depends on what you, hey, that line is crooked. See one more time. That's good enough. So it just depends on what method you want to use. I didn't see anywhere where they made you use the slope method, but either way, you'll get the same line.
So all of chapter 5 really is like dealing with graphing and slopes and all that stuff.
Well, I know 5.1.5.2. I haven't looked at 5.3, 5.4 yet, so, but it still should be along the same lines.
Right.
You know how they don't deviate too far from the previous sections, you know, in that chapter. So, yep.
Okay.
So try the stuff out. See if you get stuck. Of course, if you have any questions, feel free to ask.
Yeah.
Next class, I think we have 5.3 and 5.4 to close out chapter 5. And we'll do that and go from there. All right.
It's going fast now. I'm like, no. Really fast now. Like I'm scared because we only have a month left, but it's like that month really is not as long as it is. You know, it's
right. Well, it's like this is the way you should look at it. You can look at it glass half empty or glass half full.
right.
So we have a month left regardless. You know, a
Right.
month, we're really a little over, like a month and a week, a month and 2 weeks. Depends on how that December thing
Right.
go for us. So, but let's just say a month.
Yeah.
But it's not a month of lecture.
Okay.
Because, you know, we're going to be out for Thanksgiving. That whole week of Thanksgiving, we won't have, you know, anything to do. I don't know if we're missing something else. But at least we know a week of that, we won't be doing anything new.
Okay.
So even though I won't be meeting with you guys, I also won't be giving you anything new. So that gives you the opportunity to get caught up and to do things.
Yeah.
If you take advantage of that time.
No, yeah. I mean, obviously, I need to. I don't want to fail.
Yeah. And I'm just saying that I'm saying that in general. I wasn't really specifically talking to you about it. But you got to take advantage of those opportunities that we have left. Because there's still, even though it's a month, there's still plenty of time to get caught up.
I know. It's just what I'm tripping up. I mean, I'm caught up, like how we spoke in email and stuff, but I'm still on my Excels, and I'm like,
yeah.
So I don't know. I'm just tripping myself out, but I'll be fine.
Right. Yeah. And like I said, I was making general statements. I wasn't necessarily attacking your homework.
I can trust me. I know I'm going to report you now. No. No, it's just time. It feels like, you know, like it's a very serious thing, you know. So.
Right. So all right. So try the stuff out, guys. See if you get stuck. I got to hurry up and get off the Zoom before Ms. Gallup asks her question.
Okay.
So
you ready for me?
Well, did you want to wait for everybody to get off, or did you want to go ahead?
Yes, please.
Yeah. Okay. Bye, you guys. Have a good day.
Bye.
All right, everybody, take care.
Have a good one.
All right.
See ya.
Oh, let me stop recording.